In this video, we're going to discuss how to find relative maximum and minimum. And then also we're going to talk about determining if it's a turning point. Okay, so let's see. First off, relative maximum and minimum. Let's talk about what those terms mean. Sometimes they're also called local maximum and minimum because what it means is that you are the max or the min within a certain neighborhood. Okay, so within a certain local area or relative to the points that are around you. So so this would be a relative minimum. Okay, so let me go ahead and state that. So this point is a relative minimum, relative min, and the reason is that you would say, okay, well, f of -2, okay, so where x equals -2 is less than all f of x for x in a certain neighborhood. Okay, so for x in the interval, you could just say the interval right around -2, so that could be from here to there, which would be maybe 1.5 or -2.5, which is -5 halves, and then -1.5, which is 3 halves. Okay, so inside that interval, this point -2 and -2 is a relative is the lowest value. Okay, and same idea for the highest value. So here, this point -1, 1, that would be a relative max because within a neighborhood, you could define a neighborhood to be maybe -3 halves and -1/2. Right in here. Within that neighborhood, this is the highest point. Okay, so let me go ahead and, so I'm going to write this over here. So our relative min, we've already determined, oops, that one of the relative mins is -2, -2. Okay, relative max would be this -1, 1. And then down here, this one is also a relative min again, because within its little neighborhood, it's the lowest point. So that'd be 1, -1. Okay. Up here, this is a point that's just being marked, but you see it's not the highest point in any neighborhood. Okay, so this is not a relative min or a relative max, it's just a point that's been marked on the graph. Okay, so now let's talk about turning points. Are each of these turning points? So turning point means that you were going in one direction, so you were decreasing, and then all of a sudden you're increasing. Okay, and you'll see that all of these 3 points are indeed turning points. So, all are turning points. So all of the extrema are turning points. Okay, moving on to another example. When we're looking at this graph, do we see any point where in its neighborhood, right around it, it's either the lowest or the highest point? No. Okay, because say you were to choose this point here, well, there's a point that's right below it that's lower. Okay, so obviously that's not a relative min. So obviously that's not a relative min because there's a point right below it that's lower than that point that you just chose. And there's a point that's right above it that's higher than that point that you just chose. So obviously it's not a relative maximum. So there is no relative minima or maxima on this graph. Okay, so no relative min or max. Alright, so now moving on to another example. Say you were to choose this point here. Okay, so this is f of -1. F of -1 is less than or equal to f of x, okay, for x in the interval negative infinity to infinity. Why is that? Well, because f of negative 1 equals negative 2, right? And f of x always equals negative 2. For all the different values of x, f of x always equals negative 2. Remember, f of x is the y coordinate, so this is, y. Y is always negative 2. So when x equals 1, y is negative 2. When x equals anything, y is negative 2. So this is the equality in this. Okay? So f of negative 1 is less than or equal to f of x, regardless of what x is. Well, that's the definition of a relative minima. We also know, f of negative 1 is greater than or equal to f of x for x in the interval negative infinity to infinity. This is the definition of relative maxima. So f of x, so all points are relative minima, and all points are relative maxima. So I'm going to go ahead and write that. So all points, and we can write this in terms, so we can write x, so the x coordinate, and then the y coordinate is going to be negative 2 because it's always negative 2. So all points are relative min and max, okay, on the interval negative infinity to infinity. Now, are any of these, they're all extrema, so are any of these points turning points? No, right? Turning point would mean you'd be going from being decreasing to increasing. And we're never increasing and decreasing on this graph. We're always constant. So there are no turning points. All right, moving on to the last example. Now, this graph is the graph that we had in the previous video. So let's go ahead. Let's get started to it. So let's talk about our relative. First, let's talk about our relative max or min, our relative min. So where are our relative mins? Okay. So this is 1, right? In its neighborhood, it is the lowest point. Okay. So there's one relative min, negative 2, negative 2. All right. So as I'm moving along, I found 1. Okay, is this a relative min? Right? Remember, in order for it to be a relative min, then we would have to say, okay, f of x equals 1 there. So f of 1 is less than or equal to f of x, for x in some local interval. So for x in the interval, so say you were to go from 1/2 to 3/2. Okay, so just go in some interval that's really close to 1. Is it the lowest point? Is it less than or equal to? Yes, right? Because it's higher up here, and it's equal to over on the other side. So yeah, so another relative min is 1, 1. All right, so now let's talk about our relative max. Oops, let's go ahead and erase that. So a relative max, so we have, we have a relative max here. Same reason that this is a relative min, this is a relative max. If you were to go in the area around, this value is higher or equal to the points that are in its area. Okay, so there's a relative max. Negative 1 to 1. Then also negative 2, 2, this one over here is also a relative max. Okay, what about all these points between here and here? Just like how we did in the previous example where we discussed, all the points that are on a line like this are both relative max and relative min. So let's go ahead and write that. So all points, okay, x, comma, now what's the y value? Y on this line is 1. So all points x comma 1 are relative min and max on the interval. Okay, what interval? So you start at -1 and then you go all the way to 1 where that line is. Okay, lastly, are there any turning points? Yes, so remember turning point would be where you're increasing and then you go to be decreasing, or decreasing and you go to be increasing. So this is a turning point and this is a turning point. Those are your only two turning points. These other ones, -1 and 1 and 1 and 1, those 2 points are not turning points because you're going from increasing to constant or constant to, decreasing, or, so you have to go, so going to constant doesn't make you a turning point. Okay? So let's see, I will go ahead and write that. So turning points are -3 or -2, 2, and 2, 2.